So, as we continue our study of ecology and organisms and their ecosystems, we're going to look at how organisms have changed over the course of time and how we've figured out that we think organisms have changed over time. To do that, we're going to look at something that's not living at all: cell phones. So, looking back in time, the very first cell phones that existed were very simple. They were made to make phone calls. They were big, they were clunky, that was it. And as people's needs have changed over time, the characteristics of the phones have changed over time to meet the needs of people. And now today, phones are far more complex and they can do so many more things. And they're very much designed for the needs that people have now. This is really similar to organisms over time. And one of the very first people to notice this was Charles Darwin. So, Charles Darwin was a voyager. He traveled around the world and he started to make some observations about the places he was visiting. One of the things that he really noticed was the variations or the differences among animals depending on the island that he was at. So, as he was visiting different islands, he noticed that the landscape of the island was different. The vegetation, the abiotic factors, maybe the rocks, the soil, the structure of the island looked different, which created different food sources. It created different living spaces, shelters for the animals. And he really noticed that the animals that lived there were different as well. So he noticed that on all the islands, or on many of the islands, there were both tortoises and a bird called a finch, but the characteristics of those animals were different. So the finches, we'll start with the finches, their beaks were different. So the birds themselves were all the same type of bird, but the shape of the beak varied depending on the food that was available. So, on islands where there was a lot of flour with sweet nectar to eat, the birds had long, pointy beaks. And on islands where they were more eating seeds, the birds had short, rounded, stronger beaks that could break open those seeds. He noticed something very similar with the tortoises as well, based on the food that was available. Some tortoises had long necks and some tortoises had short necks, and that varied from island to island. It wasn't different all on the same island, it was different based on the island he was on. So Charles Darwin took what he learned and he went home and he actually used his hobby with pigeons to help him show how organisms can change over time. So he took his pigeons and he was able to choose parent pigeons that had traits that were best suited for what he wanted to have happen. Maybe it was fly a certain distance or fly a certain speed. And he took the parents that had the best traits and he bred them together to try and get the perfect pigeon. And he then used this as an example to show how organisms in nature could change over time. He was just able to speed this up by choosing the best parents and breeding them to get the quote unquote perfect offspring. And we call this artificial selection because it is being done by choosing the parents rather than nature just letting the best parents survive. So, artificial selection is the selection and breeding of organisms for desired traits. So, it's when humans come in and choose the best traits. And we see this in our world around us. One of the biggest places we see this is in our grocery store. Believe it or not, cauliflower, cabbage, Brussels sprouts, broccoli, kale, these all stemmed from the same parent plant. And people came in and they said, oh, I like these characteristics and these characteristics, and they bred them together. And they ended up getting different varieties of plants. And based on the traits that they preferred, they would breed them together and they got broccoli. And then, based on different traits that they preferred, they would breed those parent plants together and they got Brussels sprouts or cabbage or cauliflower. The University of Minnesota is another great example of this. So, the University of Minnesota is very famous for their ability to selectively breed for apples. They take apples, and it takes many apples, like 30,000 apples, to get to the one final apple that they like. But they take a whole variety of apples and they test them and they say, "Ooh, we want an apple that has a really long shelf life. It can survive on the shelf for a long time. And we want it to be sweet because we like sweet apples." So they might take a parent plant that has a long shelf life and a parent plant that has sweet apples, breed them together, and hope that they're going to get an offspring that has sweet with a long shelf life. They will keep doing this until they end up getting some of the best apples that they choose. And in that process, they get a whole variety of apples. We do this with dogs too. We're very familiar with dog breeding, but we don't really think about it as the technical name, selective breeding. So people come in and they breed particular dogs together to end up getting specific traits that they want to get the perfect dog. The perfect dog might be a dog that is low in allergies. The perfect dog might be a really great hunter. The perfect dog might be really good at herding or have a really great ability to track a scent. So, depending on the goal that the breeder wants to have happen, the breeder can choose the parents and then hope to get the best offspring. It's not guaranteed, but they can speed up the process of which traits will be passed on by choosing the parents that have the best or the traits that they would like and hope that those are the ones that get passed down. That's a little bit different than natural selection. So Charles Darwin thought, well, this is the same thing that's happening. It's just happening faster with my pigeons, and I'm seeing it happen in nature. It's just taking a lot longer. So here's what he saw. He was seeing a cycle happen, and that cycle is natural selection. So the technical definition of natural selection is the process by which populations of organisms with variations or differences that help them survive in their environment live longer, which means they compete better and they reproduce more than those that don't have the variations. So let's look at what this looks like. It's just a cycle of reproduction, variation, competition, and selection. So this is the fast version, and then we're going to go through it in detail. So we saw this natural selection with the tortoises and with the finches. So one example here is the tortoises are reproducing. They have a whole bunch of offspring that inherit their traits, and then they have a variety of traits. Some necks are different than others, and the organisms that have the traits that are best suited for their environment allow them to survive or compete with the organisms that don't have the best traits for their environment. When the ones that have the best traits get the most food or the best shelter, what happens is they survive and nature selects, or they're able to last long enough to be able to reproduce. So let's look at this in detail. So the first step of this cycle is reproduction. So reproduction is when a population, in this case of tortoises, reproduces and it makes more offspring than needed. We call that overproduction. And those offspring inherit traits. They inherit the characteristics from their parents. So organisms create new offspring and pass their characteristics or their traits on to their offspring. Then, when they do that, that creates variation because siblings don't all look identical. Same with tortoises. Tortoise siblings don't all look identical. And sometimes mutations happen. And that also creates changes for tortoises, maybe it's the length of their neck. So variation is the differences in the characteristics from organism to organisms. So the differences in the characteristics from organism to organism. And that variation in a population comes from mutations in the DNA. So variations are created through the passing of DNA, and that mutation happens at random. They aren't chosen, it's just random. So when those mutations happen, it creates competition. And so organism that is best suited for the environment is going to be able to survive. So organisms that can survive in that ecosystem have a better chance of then lasting to be able to reproduce. So we call this ability to both survive and reproduce fitness. And organisms that have a high fitness are more likely to survive and reproduce. Organisms that have a low fitness are less likely to survive and reproduce. So those organisms that survive and reproduce have then been selected. Now, when we say organisms have been selected, nature is not going, ooh, I choose you and I choose you. It's just that the organisms that are best at finding food or have the ability to find shelter are also the organisms that are able to survive and reproduce. So organisms are selected when they have the traits that are best suited for their environment. And that happens randomly. So selection in nature is very random. It's the organisms that are able to survive. And we call that an adaptation. So an inherited trait that increases an organism's chance of being able to survive and reproduce in a particular environment is called an adaptation. I'm going to say that one more time because that's a really important one. An inherited trait that increases an organism's chance to survive and reproduce in a particular environment is called an adaptation. So let's look at this using a different organism. So natural selection in a nutshell. Here we have a bunch of green beetles and a few red beetles. And these birds are saying, ooh, green beetles, our favorite. And they can see the green beetles and they're able to catch the green beetles. But over time, these green beetles keep getting eaten and the little red beetles are able to hide. And so generations later, that gives the red beetles a chance to reproduce. And they have this camouflage. They're not being seen by the birds, so so their green beetles are not surviving and the red beetles are. And then eventually the green beetles possibly have been selected against, and those reddish brown beetles have really flourished, and so they have been naturally selected. Nature wasn't going, ooh, I like the red beetles better. It's just that they had the ability to hide. So natural selection does happen differently when it occurs in nature versus artificially. In natural selection, it occurs based on the traits that allow an organism to survive. Artificial happens when people come into the situation and choose organisms that have traits that they really want them to have, and then make or attempt to make the perfect or best organism suited for the task. Kind of like cell phones. Choosing an organism or a cell phone that is best suited for the task. When people become involved, we call it artificial selection.